So, hello viewers, as we are discussing the reactions of carbenes, so this is another important reaction, Bamford Stevens reaction. So, in this reaction, this is the base catalyzed decomposition of aryl sulfone, this molecule is hydrazone, to form alkene. So, Bamford Stevens reaction, an aldehyde or ketone is converted into, after reaction with aryl sulfone hydrazide, it is converted into hydrazone. Then this hydrazone is decomposed in the presence of the base to an alkene. So here the starting material could be the aldehyde or ketone. So in this, first we form the hydrazone. Basically this carbonyl oxygen of this aldehyde or ketone and this H2, this NH2 molecule is H2, this is water, this nitrogen and this carbonyl oxygen, they react and this water is removed to form this hydrazone derivative. This hydrazone is then decomposed with the base. Base is usually metal alkoxide. So this base, there are here the two cases. When this reaction occurs in the presence of the aprotic solvent, then the carbene mechanism it follows to give predominantly Z alkene. More proportion or exclusively the Z alkene is formed. Here this wavy line shows that although it is an exclusive product Z alkene, but a small little amount of E alkene is also formed. But when this reaction is catalyzed, is done in the presence of the protic solvents such as methanol or water. Protic solvents have this H protons, like this one. In methanol, this one is OH has the H proton. In water, this again OH. So in aprotic solvent like dimethyl formamide, dimethyl sulfoxide, diethyl ether, tetrahydrofuran. So this is the second case. When the protic solvents are used, we get poor selectivity. We get the mixture of trans and cis olefins. So here the used Z is used for zucimane. This is a Latin word which means cis, and its E stands for entgegen. This is another Latin word which means trans. So this is the mechanism of this reaction, Bamford Stevens reaction. First step in this reaction is the formation of the hydrazone, as we started from ketone. So first step is the synthesis of the hydrazone. So this aryl sulfonide hydrazide NH2 and this nitrogen lone pair attacks on this carbonyl carbon of the ketone. So this 2 electron is shifted on here. So then from this one of the hydrogen atom on this NH2 moiety, this proton shift occur, make its OH, and then the removal of the water molecule from here. This proton and this OH is removed, and we get here a double bond between the nitrogen and this carbon to make this hydrazone moiety. So later on, this base, which base has a lone pair, this attacks on the nitrogen NH, and this its base takes this NH proton. So when this takes the proton, here the negative charge is generated. So when this negative charge basically this negative charge, then this lone pair is shifted here, and this aryl sulfonyl is removed. This group is removed to make this diazoalkane. This diazoalkane, this charge on this negative charge on this nitrogen is come back, and it's here the 2 electrons is shifted over here. So later on, when this in the presence of the aprotic solvent, carbene is formed. So from here, this nitrogen is removed, and then we get a carbene. Carbene undergoes 1,2 hydride shift. So this hydrogen atom with this bonded pair of the 2 electrons is shifted over here, and these 2 valence electrons of the carbene is shifted here to make the double bond, to make the basically alkene. Here as we told, this with the presence of the aprotic solvent, Z alkene is formed exclusively or predominantly, and small amount of the trans alkene here. So this is the first case. Second case, when this reaction occurs in the presence of the protic solvent, this diazoalkane is when this charge from the nitrogen comes over here, 2 electrons shifted here, then this protic solvent this negative charge gets the proton from these product solvents. So here this another single covalent bond is formed between this carbon and the hydrogen. Later on this nitrogen is removed to form this carbocation intermediate. This carbocation intermediate, when it's undergo the elimination, this H is eliminated, so make this alkene. So this alkene is, we get is a mixture of the cis and trans alkene, so poor selectivity in this case. Through this when this goes through this product solvent, when used, we get the poor selectivity, we get the mixture of the E and Z olefins. So this is the overall explanation of the Bamford Stevens reaction. So we starting with this aldehyde ketone, we make the which reacts with the aryl sulfonyl hydrazide to make this hydrazone. Then in the presence of the base, this hydrazone decomposed. Now there are two cases. When we use the A product solvent, we get this Z alkene predominantly. When we use the product solvents like methanol or water, we get this mixture of E and Z olefins. So this is the summary of this reaction. Thank you very much for paying the attention, and thanks.